Bismillahirrahmanirrahim. Process of dimensional modeling is the name of the topic. So the process of dimensional modeling. So basically, a typical ER diagram covers the entire business. Actually, covers every possible business process. As a consequence, ER diagram is overly complex. A single ER diagram can be divided into multiple DM diagrams, dimensional modeling diagrams. Thus, a stepwise approach is followed to separate the DMs or dimensional modeling diagram from an ER diagram, and this consists of this is a four-step method. So step 1 is to separate the ER diagram into its discrete business process and to model each business process separately. Second is to choose the grain. What is the meaning of one fact table row? Third is to choose the fact. Basically, best facts are numeric and additive, non-key items. And you have to choose that and designate them as in fact tables. So actually all business events to be analyzed are gathered into fact tables, and choose the dimension. Denormalize all the remaining tables into flat tables with single part keys that connect directly to fact table. These tables become the dimension tables. They are they are typically small as compared to fact table and relatively static. So first step is to choose the business process. So a business process is a major operational process in an organization. Basically, in ER model, all business processes are covered. So typically supported by legacy or OLTP systems, such as order processing, operational process, invoice generation, inventory, etc. So you have to separate business process from, you can say, ER model, and you can generate multiple star schemas that covers individual business process, and you can generate multiple star schemas from that ER model. So second step, while conversion from an ER model to dimensional model, is to choose the grain. So grain is the fundamental atomic level of data to be represented. So grain is also termed as unit of analysis. So what level of detail you are placing in your fact table, that represents grain. So typical grains are, you can place individual uh, transactions in the fact table, but usually you work with aggregates. You can place daily aggregates, you can place monthly aggregates, you can place yearly aggregates. So what level of detail you place in the fact table is represents your grain. For example, uh, this is the fact table. Now this is each row of fact table. So now this fact table represents the quantity and sales revenue per date, per store, and per product. You can place the grain like per month, per district, or per city, and per product as well. So what level of detail you place in your fact table represents your grain. So we need choose fact statements. So from this statement, you have to identify what are your facts and what are your dimensions. So as you can see, these are numeric values that are, you can say, additive. So this represents your facts, and these are dimensions, as these attributes have hierarchy. So choose the facts that will populate each fact table record. Best facts are numeric, continuously valued, and additive. Like example, quantity sold, amount, etc. So uh, additive and versus, you can say, non-additive facts. So additive facts, you can add them, and when you add them, uh, that gives you the correct result. These are called additive facts. Summing the fact values give meaningful results. Like if you add the quantity sold uh, per day per day, you can get quantity sold per month. Or if you add the quantity sold per month, you can get the quantity sold per year. So active facts are those that if we add them, gives you meaningful and valid results. Non-additive facts are those uh, that if you add them, they will not give you valid answer or meaningful result. Like if you add averages, two or three averages, uh, the result will not be valid. In the same way, percentage ratio, if added, will not give you a valid result. Next step is to choose the dimension that um, apply to each fact in the fact table. So basically, you have to see that uh, you have to analyze fact by what. So typical dimensions are time, product, geography, or location. Whatever attributes for which you can make hierarchy. So identify the descriptive attributes that describe the facts that explain each dimension. Determine hierarchies within each dimension. So in this slide, you have to identify among these attributes what are facts and what are dimensions. So date attribute can make hierarchy, store, product. As you can see, these are the descriptive attributes. So these are your dimensions. In the same way, quantity, unit price, sales amount are uh, numeric measurements that you can say are additive. So these correspond to facts. And transaction number is you can say is a key attribute. So that is not a fact but placed in the fact table uh, because facts are non-key attributes. So this is a case study. Uh, Consider a system simply explained as it has users so and groups of users, user groups and users. So every user can perform certain actions like message, comment, meeting. For every action, user gets some points that are also added to the points of user groups that this user belongs. So the system also has many other features that are not relevant to points, and let's assume the system has over 100 tables to store various things. So identify, you have to identify business process. First is that do we start doing dimensional modeling to all by taking into consider all 100 tables? The answer is no. You have to uh, choose only those business process that is relevant in analysis. So you don't have to proceed with all the tables in the or all the processes in the ER model. So which tables should be selected? The tables that are relevant to the business requirements. So three types of points are required for reporting: per month points. So means per month grain should be set, average lifetime points at the end of each month for individual users, user groups, individual user per action, and user groups per action. So what are the actions that I told you in the previous slides? So grain is what? What does one row in fact table represent? So it can be per month, per user, per individual per month, per user group per month, per user uh, per action per month. So this represents your grain. So these are the dimensions. So these facts are identified to be placed in the fact table, and this is the star schema. This represents points, monthly points, lifetime points, and average points per user per date. So the grain is per individual, and as you can see in the date table, the grain is month. So it in the fact table, it represents points per individual per month, per individual per month, and average lifetime points per individual per month. So average lifetime points per individual per month. So now this fact table represents points per individual per action per month, and lifetime points per individual per action and per month. So in this way, you choose, you first identify the business process that you have to cover in your dimensional model. Then you have to identify the facts, dimensions, and then you have to make star schema of it.